When you are drawing Lewis structures, the first thing you want to do is start with a plausible skeletal structure. The central atom is usually the least electronegative, which means it's furthest from F on the periodic table. Hydrogen and fluorine are going to be terminal positions, which means they're going to be outside in the structure. And we'll talk about oxyacids a little bit later. You want to add up the total number of valence electrons. That's the number of electrons that must appear. We cannot lose or gain electrons in a Lewis structure. And then we're going to place the electrons around the atoms in such a way as to complete an octet for most of the atoms. And what I do is I start on the outside and work my way towards the middle of these structures. You can use this formula if you'd like. The number of shared electrons can be obtained from the equation n minus a equals s. N is the number needed, A is the number available, S is the number of electrons shared. Now this equation will only work if it's not an exception, but you can certainly use this equation to see the number shared. So write the Lewis structure for hydrazine, N2H4. We have three possible skeletal structures, but since hydrogen has to be terminal, A and B are not going to work. C is the only structure that is going to work because hydrogen has to be a terminal atom. If we do the equation N minus A equals S, N is the number needed. Well, I have 2 nitrogen. Each nitrogen needs 8. And I have 4 hydrogen. Hydrogen only needs 2. So the total number needed is 24. The number available, I have 2 nitrogen. Each nitrogen has 5 available, 4 hydrogen, and they have 1 available. So that's 14. N minus A equals S, which is the number shared. There would be 10 shared electrons. So the Lewis structure, hydrogen has 1. Start on the outside and work your way towards the middle. Nitrogen has 5. So there is the correct Lewis structure for N2H4. The number shared, I'll circle those, and there are indeed 10 electrons that are shared. Okay, now let's look at HCN. The central element is usually the least electronegative. Well, carbon is less electronegative than nitrogen, so carbon's going to be in the middle. Hydrogen has to be on the outside. We could do N minus A equals S. Number needed, hydrogen needs 2, carbon needs 8, and nitrogen needs 8. Total of 18. Available, hydrogen has 1, carbon 4, nitrogen 5. 18 minus 10, number shared, is 8. So hydrogen has 1. Nitrogen has 5, and carbon has 4. So I tried a single bond. The single bond did not work because carbon and nitrogen, neither one, have 8 valence electrons. So I'm going to have to move electrons, in this case, to form a triple bond. And the correct structure looks like this. In a triple bond, 6 shared electrons allows carbon and nitrogen to have 8 valence electrons. The number shared, 2 here, 6 here, added up to the 8 that I got from the N minus A equation. So this is the correct Lewis structure for HCN. Now we're going to look at oxidation states. The electrons in the covalent bond are assigned to the more electronegative element. The oxidation state is the number of valence electrons minus the number of electrons assigned. So let's look at AsF3. First off, draw the Lewis structure. Fluorine's on the outside, arsenic's in the middle. Start on the outside and work your way towards the middle. Each F has 7. Arsenic has 5. For oxidation state, the electrons in a bond are assigned to the more electronegative atom. So if I'm comparing F to AS, F is more electronegative, so these electrons go to F, these electrons go to that F, and these electrons go to that F. So oxidation state. For fluorine, we had 7 to start with, and we're going to subtract the number assigned. Each F is assigned 8, so each F has an oxidation state of -1. For arsenic, arsenic started with 5. The number assigned to it, there's only 2 assigned to it, so arsenic has an oxidation state of +3. Let's look at one more molecule, HCN. Do the same thing with oxidation state. First off, Lewis structure. The electrons are assigned to the more electronegative atom. So between carbon and hydrogen, carbon gets those electrons. And these electrons between carbon and nitrogen, nitrogen is more electronegative, so nitrogen gets those electrons. So for oxidation states, hydrogen had 1 valence minus the number assigned, 0, so +1 for hydrogen. For carbon, number of valence was 4 to start. The number assigned is only 2, so +2. For nitrogen, nitrogen had 5 valence to start. The number assigned to it now is 8. So oxidation state is -3. The sum of the oxidation states is 0. Formal charge. Formal charge helps us to choose among different possible structures. In computing formal charge, all non-bonding electrons are counted as belonging entirely to the atom in which they are found. Bonding electrons are divided equally. So the difference between oxidation state and formal charge is that formal charge are divided equally, whereas oxidation state, they went to the more electronegative atom. Lewis structure for HClO. There's 2 possibilities. Chlorine and oxygen are very similar in electronegativity if you look on the periodic table. So either one could technically be the central element. So in the first structure, with chlorine as the central element, it would look something like this. And then with oxygen as the central element, it would look like this. Formal charge is the number of valence minus the number assigned, and that will give you formal charge. For hydrogen, 1 valence for hydrogen, for chlorine, 7, and for oxygen, 6. That's how many we start off with. We assign electrons by dividing electrons in the bond equally. So if you have a single bond, 1 goes to hydrogen, 1 goes to chlorine. In this bond between Cl and O, 1 goes to O, 1 goes to Cl. I'm just dividing these electrons equally. So for hydrogen, the number assigned is 1. So the formal charge on hydrogen, 0. For chlorine, we got 1 here, and we got 2 pair on either side, so that's a total of 6. 7 minus 6 gives you a formal charge of plus 1 for the chlorine. For oxygen, 1 from the bond, and then 6 around the oxygen, that's 7. Formal charge, negative 1. For the next structure, hydrogen has 1, formal charge 0. Oxygen, 1 from each covalent bond, 2 unshared pair, that's a total of 6. 6 minus 6, 0. For chlorine, 1 from the bond, and then 6 around it. So chlorine has a formal charge of 0. A Lewis structure where there are no formal charges is more plausible than one where formal charges are required. So the best structure is this one right here, because the formal charges of each element are 0. Even though oxygen is a little more electronegative than chlorine, it is the central atom in this case. For oxyacids, the oxygen atoms are bonded to the nonmetal atom, and the hydrogen atoms are bonded to oxygen atoms. For example, H3, PO4. P would be in the middle, oxygen would surround the phosphorus, and the hydrogen are bonded to the oxygens, and there are 3 H's. Start on the outside and work your way towards the middle. Hydrogen has 1. Then you do the oxygens, 6. And then P has 5 valence electrons. So this compound works out nicely with all single bonds.